Hey everyone, it's the AP Tutor here, and today we're going to be looking at some related rates questions for AP Calculus AB. Before we get into it, I want to go over the same basic steps you will take for every single related rates question. The first step is to draw a diagram. The second step is to define your variables and the question. The third step is to relate your variables. The fourth step is to differentiate your equation in which you related the variables. The fifth step is to plug in your known values. And then your sixth and final step is to just put in the right units. Never forget that in math. Okay, so let's take a look at our actual question. The minute hand of a clock is 4 inches long, starting from the moment when the hand is pointing straight up. How fast is the area of the sector that is swept out by the hand increasing at any instant during the next revolution of the hand? Now that's a whole mouthful, and it might be overwhelming at first, but let's slow it down and follow our workflow. The first thing we do is to draw it out. And we know that it's a clock, so it's going to be circular. We know that the minute hand is pointing straight up, right? So that goes from the center of our circle all the way to the top because it's a minute hand. And we also know that it's 4 inches long. They tell us that much. Very nice of them. So what do we want to know? Well, the question is asking us, how fast is the area of the sector that is swept out by the hand increasing at any instant? So we can imagine that our minute hand over here is moving clockwise, right? Let's say it moves down to here. And it forms an angle there, and the area that it has been swept through, we define as the area that has been swept. All right, perfect. Let's put down what we know. We know that the radius of our circle is 4 inches, and we're looking for the rate of change of our area swept. That's what we're looking for. Let's see if we know the rate of change of our angle theta here, right? Actually, we do. They don't explicitly tell us in this question, but this is something that we can figure out because we know how fast a minute hand sweeps, right? We know that it goes from here all the way down to here in 30 minutes, right? In 30 minutes. And in terms of radians, this is pi radians, right? So we know that the rate at which our angle changes is pi radians per 30 minutes. All right, perfect. Now we're done with step 2. Let's do step 3. We need to put together an equation that relates together all of our variables so far. So we have the area of the sector, and we want to relate that to the radius as well as the theta, our angle. And the formula for that is 1 over 2 r squared theta. This is simply an equation that you need to have memorized, but let's say you forgot it. There's no worries, right? Let's say I have a circle here with a theta, and I know that the area of a circle is pi r squared, right? And I know that my area of my sector is proportionate to the angle of my circle, right? Theta over 360. That's going to be the ratio to it. So this is my area of the sector. 360 degrees is equal to 2 pi radians. That's a conversion from degrees to radians, right? So if I sub in 2 pi down to here, what do we get? Get pi r squared times theta over 2 pi, which is 1/2 r squared theta, which is what we have up here. So We're done with step 3. Let's move on to step 4 and differentiate. So we're differentiating everything with respect to time. So that's why it's d over dt times d dt 1/2 r squared theta. All right. And if we'll recall, r isn't actually a variable, right? The size, the length of the minute hand never changes, and we know the length of the minute hand as well, and that's 4. So let's plug that in really quickly before we go any further. Theta. All right. And that simplifies to d dt 8 theta. All right. Then I'll just put it all together nice and neatly. d dt times is d dt 8 theta. All right. And then actually doing the differentiation, we get the dA dt is equal to 8 d theta dt. Great, so that was step 4. Now let's move on to step 5, plugging in the values. So what value do we have? We have d theta dt, and that's 8 over 30 radians per minute, right? So let's plug that in. It's 8 times pi over 30 radians per minute. And our final answer is going to be 4 pi over 15 inches squared per minute. Why is it inches squared? Because the area that we're calculating for is in inches. Okay, now let's look at a second example. The grain pouring from a chute at a rate of 8 feet cubed per minute forms a conical pile whose height is always twice its radius. How fast is the height of the pile increasing at the instant the pile is 6 feet high? All right, so the question is a little bit different now, but we still approach it the same, right? Again, remember step 1 is to draw out a little diagram. So we have a cone shaped, right? And our cone is defined by its height and the base, which has a radius of r. And when you're defining your variables, 90% of the time for these related rates questions, you want to define your variables in terms of the variables that you use when calculating things like area or volume. That's why we're using h and r here. All right, now let's take a look at the actual question. So they tell us this, 8 feet cubed per minute is the rate at which the grain pours in. So that's the rate at which the volume changes, right? The volume of our grain changes. So dV dt is equal to 8 feet cubed per minute. All right, what else do we have? Well, it also tells us the relation between the height and the radius, right? The height is always twice its radius. So h is equal to 2r. All right, so what is it that we want to know? Well, we want to know how fast the height of the pile is increasing at the instant the pile is 6 feet high. How fast the height. All right. And remember, every time you see something like how fast or how quick, you want to be thinking of derivatives because that's the rate of change. So the rate of change of our height, we can call dh dt. Let me stick with the lowercase here. dh dt when h is equal to 6, right? 6 feet to be exact. Now let's relate all the variables we have together in a single equation. So we have height, we have the radius, and we know that at some point we're going to be using volume, right? So it's probably going to be volume. So the volume of our cone is 1 over 3 pi r squared times h. And this is just the formula for the volume of any cone. All right, and let's see, radius isn't changing. Um, and we know the radius in terms of height, so we can plug in for that, right? So if we wanted to get rid of radius, we plug in h over 2. So let's do that before we take our derivative. Times h, and simplifying all of that, we get 1 over 12 pi h cubed. Okay, so now that we have our equation, let's do the actual derivative. We're differentiating again everything with respect to time. d dt 1 over 12 pi h cubed. All right, and actually doing this, we get dv dt is equal to pi over 12 times 3h squared dh dt. And let's just simplify that a little bit more. dv dt is equal to pi over 4 h squared dh dt. Okay, before we plug in what we know, let's solve for dh dt first. Let's make things a little bit neater. So dh dt is equal to dv dt times 4 over pi h squared. Now let's begin to substitute in what we know. We know what dv dt is, right? That was our 8 feet cubed per minute, because the rate at which the grain pours in is the rate at which our volume changes. So 8 feet cubed per minute times 4 pi over pi. And what is h? Well, h is 6, right? That's the height which we're interested in solving for. 6 feet squared. All right, let's simplify that a little bit more. So that's 32 feet cubed over 36 pi feet minute. All right, and now it's just a little bit of stoichiometry. The feet cancel out. That was feet squared, right? The feet cancel out. So you're left with 1 feet in the numerator and a minute in the denominator. And your final answer is 32 over 36 pi feet per minute. All right. Hopefully that clears up a little bit of the confusion about related rates. And remember, while the question might change and sometimes they might throw curveballs at you, just refer to the same workflow that we went over at the beginning of the lecture, and staying calm, doing it that way, you'll be able to do any related rates question.